percent 3% B percent S to check for like weird stuff, but that doesn't seem to be working.
So if you have 3 command line arguments, then you have the following.
The low rate and the high rate, right, from those 2 numbers.
Right. So let's
Mine's just saying sorry, invalid integer, kicked out. It's going to be the else statement for that one. So I think I'm doing it wrong.
Yeah. So if you say something like main 100 200, you know the following things. You know argc is equal to 3. This is argv bracket 0. This is argv bracket 1, and this is argv bracket 2.
No, we're not seeing this thing.
That would help. There we go.
Okay.
So if you got 2 command line arguments, you can detect that by looking at argc, seeing that it's equal to 3, and once you've done that, then you can use argv bracket 1, argv bracket 2 to be those 2 command line arguments.
Oh, so you would just do basically 2 scanf.
Yes, exactly.
Okay, so one would be basically reading argv1, making sure it's valid, and then the next one argv2, make sure it's valid, and we would declare the integer valid.
You got it.
Okay. Got it. Perfect. Thank you.
All right. All right. All right. Yeah, send me an attendance ping up front here. And return the valid integer height equals low equals gamma and high equals high. Cool. Yeah, you can make a function that takes a string and returns an integer. Make sure you have a way for it to tell you if there is a syntax error, though, so that if the person types in something that's not a valid integer, you can detect that. And all kinds of possibilities on this assignment to modularize. And I plan to spend a good part of tomorrow talking about PA3 in terms of, well, I want to talk about string processing for picking up the HL and C. I want to talk about ideas on how to sort of, develop this from a simplified version to a more complete version. And I want to talk about make files, and then we'll go back and talk about GDB. And so we'll have lots of stuff related to PA3 tomorrow. But today I want to start off by talking about the midterm. Turns -1 if there's an error, and an if statement will defect that. Cool. Good. Sounds great. All right, so let's talk about the midterm. So, a few comments to make here. First, I want to talk about some general comments regarding the exam and the midterm and the course, and then we'll go ahead and we'll dig into particulars for each question and look at how we could answer each question. But let me start by talking a little more generally about the exam and the course. So the midterm is kind of an assessment option for you, possibly more than for me, right? It's 20% of the grade, but the final is cumulative, so the final counts a lot more. There's almost always a generous curve at the end of the course, and so even if you didn't show up and you got a 0 on the midterm, right? You're not out of the course by any stretch. The real important thing about the midterm is if your grade was lower than you think you could have done or you wanted to do, right? It's an opportunity to course correct, and there's a number of ways to make that happen. but we can think about, you know, changing the way in which programming assignments are done, for example. So let's take the ODPs, right? The one-day programs. The idea behind the ODPs was to encourage students so that if we spend the day talking about, you know, how to use scanf, for example, you go from class and there's a one-day program that has you use scanf. And if you really understand what you're supposed to, you can write that pretty quickly. And if you don't, then you have to figure out some things. But more importantly, if you think you understand how to use scanf, but you really don't, you'll discover that right there, that day, because you'll be writing the ODP and it won't be working. And it will compel you, hopefully, to dig into what scanf is doing, to ask questions, to write some test code, and so on and so forth, until it makes sense and it works. And then the next day, you know, we go over, you know, function calls, and there's an ODP related to function calls. So if you're doing the ODPs, for example, by trial and error, if you're writing code and it doesn't work, you try something else, it doesn't work, you try something else, it doesn't work, and especially if you're using the assessment tool to kind of, you know, play warmer, really warm, really hot. Make some changes, and now you're getting almost all the tests, and make some more changes, and so on, right? At the end of that, you might get 100 on the ODP, but you're probably not getting what you're supposed to get out of that assignment, which is, you know, understanding some core concept. So one thing you can think about maybe is how are you doing the programming assignments and the ODPs? Ideally, you know, when you write an ODP, it's not a surprise if it works. It's a surprise if it doesn't work. And in the end, when it finally works, you should really understand why every other version of the program did not work and why it did what it did. Right? It should not just be a keep trying until you get a good enough grade kind of thing, because, you know, that's not going to translate to doing the exams. So you want to try to understand your code, and you want to try to work to where your code is, you know, where you believe your code is going to work, and you have good confidence in that. And ideally, you know, that confidence is justified, so that when you write code on a test, or a job interview, or, you know, whatever, there's a good chance it's going to be mostly correct. Thank you. Well. And someone asked the average on the midterm. So the average on the midterm was around 70. And that was actually lower than I expected it to be. But we'll talk about specifics that happened.
I didn't do badly on the midterm by any means, but I looked at, I missed most of the points on question 2, and then I looked at my program, and I just forgot the second conditional, like, just do the statement on it, and that right there puts me down, you know, pretty much the entirety of question 2, so it's really easy to miss a large chunk right there.
Right, and that's part of why, you know, having you write code on paper is not, you know, the best way to assess your programming. And, you know, other than an interview or something like a test or that kind of situation, that's not what you're going to be doing as a programmer. You're going to be in an editor, you're going to be using a compiler, you know, you'll probably be using an editor that checks your syntax as you type. And when you write your code, you're going to test it. And if it does something different from what you're supposed to do, it will probably be obvious. And then you'll go ahead and debug it. So excuse me. The assessment we're doing is a little artificial, but you know, it's what we have to work with right now. So so thinking about how you're doing the programming in this course can be one change that you can, you know, play around with. On the exams, you know, you're allowed to use your notes, and your prior code is included in your notes. But that's probably not the best way to be writing programs in this course. right? Starting from a program and trying to modify it. Ideally, you can write each program from scratch, right? From starting from kind of nothing, um, and write it up from there. And so that's another change you can experiment with, right? Or maybe, writing yourself a note sheet. If you can't remember integer argc char star star argv, right? Put that on a note sheet, but have kind of this one pager that you can refer to. What are the arguments to scanf, right? What's that trick we do for picking up the extra stuff? Things like that. So those are things to work with. And if testing is never fun, right? It's always kind of inherently stressful. It's timed. It's a artificial situation, right? But if those stressors are significant, right? If you feel like when you get to 11 o'clock and the exam starts and your mind goes blank, and it takes you a few minutes to kind of remember the basics and so on and so forth. That's a good opportunity to think about trying to get some sort of setup like extended test time accommodations, things like that, or if you have some situation, if you're living in your car and you're taking your exam from the front seat of your car with a battery that's failing on your laptop, right? Things like that. Come and talk to me, or talk to the DSS office, or talk to somebody, and we want this to be as equitable as possible. If test anxiety is hindering your ability to demonstrate your understanding on an exam, let's talk about that, or have a conversation between you and the DSS office. So other questions, comments about the general aspects of the exam or exams?
I have a quick question, just on a note you made on number 5. You said it's taking arguments. Does that mean a string? Because I'm looking at the code and I can see where that would probably be the case.
So the function in 5 was not supposed to take any arguments. It was just a function called reader, no arguments, and it returns an integer.
Okay.
How come we aren't allowed to compile the code? Because that opens up a whole can of worms. Stemming from the fact that when we test in person, there's no way I can have students have reliable internet access. The internet infrastructure in the building didn't support that, and so there was no way to ensure that everybody could have access to a compiler. And so historically, right, these exams have been done on paper. Well, now that people are remote and on Zoom, that's more of an option, but some people are coming to class on their phone, right? And I don't want people to have to compile code on their phone, although it has been done before. But it's just, my ideal exam would be to sit down with each person one-on-one in a room with a compiler and an editor and give them a question and watch them, type it in and compile it and debug it and so on. I feel like that would be super stressful for a lot of students, but I feel like it would actually give the most fair assessment. It's also not something that's logistically feasible because 60 students, an hour each.
That would actually remind me a lot of starting programming with my friends. I had one question. Actually, I had one question and one thing that I just realized. So for question 4, I believe I made an issue where I invoked argv2 before argv1, assuming that low would be argv2 and high would always be argv1.
Mm-hmm.
But I'm not sure that this wouldn't work.
So I'm going to say if there's specific questions about your specific answers, let's talk about those in office hours.
Okay. Okay.
Because that's going to take drilling down. But let me go through the exam and make some general comments, and that may answer some of the questions. And if not, then we can certainly pursue in office hours.
And my second question is basically the same as the first, so I'll just drop it down.
Okay. All right. Let's see. Hold on 1 second. All right, so let's go through the exam in general. So first thing was the honor statement, and I might have mentioned this in class beforehand. I probably should have mentioned it more, but right here in the beginning, there's the honor statement. So any of my exams that are done online, there's always going to be an honor statement in the beginning, and it's basically, you know, stating the conditions under which you're taking the exam and just your agreement with it. And all you've got to do is put the word honor statement at the top, and then put your name after that. When we're in person, this will be, you know, a thing on the exam, and you'll sign next to it to accept it. But that was the first thing. And so if your grade is a 0, it's probably because you haven't done the honor statement yet. Go ahead onto Canvas, just enter a comment on the submission with the words honor statement followed by your full name, and you'll go ahead and get your grade. And if you got a 0, I still went ahead and posted, you know, what the deductions were for different points, so you can add those up and see what the grade will change into. So that was the first thing, was the honor statement. Okay, question 1. Suppose two variables, num1, num2, have been assigned numeric values, so they've already got values, right? And the question says, write a bash statement to print their sum. If you wanted to do 2 statements, that's fine, but all you had to do was print out the sum of num1 and num2 in bash. And so this might be something like echo $paren num1 plus num2, and then 2 closing parens. So that was all you needed for question 1. And so let's see, let me play along with my notes and see what kind of issues people ran into. So main issue there was not doing the $paren. That was probably the main thing people ran into, trying to just do num1 plus sign num2 or something like that. All right, question 2. Suppose two variables, num1, num2, have been assigned numeric values. Again, you don't have to give them values. You don't have to do a read statement or anything like that. They've already got values. You're writing some bash code to print out the smaller of the 2 values. And so you can do something like an if statement. So if $num1 is less than num2, then echo num1, else echo num2. there's other ways you could do this. So some people said if num1 is less than num2, echo num1. If num2 is less than num1, echo num2. And in a number of cases, the logic that people wrote ended up not printing anything if the numbers were equal to each other. And I took off a bunch of points initially, and then I went through and changed it to fewer points. And eventually I changed it to 0-point deduction. Because, you know, I probably could have been clearer on that, but if you're trying to write a function that prints the smallest of two numbers, right, and the numbers happen to have the same value, just print out the value of that number. And if you're not sure what to do if the numbers are equal, you can always ask. But nonetheless, there were submissions where if num1 and num2 were equal, nothing would be printed. So I put a comment in there saying, you know, prints nothing if they're equal, but I didn't take off points for that in the end. But if you tried to do this with a less than and a greater than, just make sure you're aware that this less than that, this greater than that does not cover all the possibilities. There's a third possibility, which is these are equal. But this is a case where an else statement sort of like subsumes all of that, right? Because if num1's smaller, we print num1. If num1's not smaller, we can just print num2. And whether num2 is smaller or equal, we'll still end up printing it. Alright, so anything else on question 2? You got to use the double brackets for ifs, which almost everybody did, so that was great. Make sure there's spaces in there. I didn't take off for spacing because people got tripped up on spacing formatting wise, but you know, make sure when you write code you've got spaces in there. Some people got the comparison backwards and ended up printing the larger instead of the smaller, so details. And I would say in general on the exam, a lot of points were lost to details, where the submission just didn't do things that the question was asking for, or did things differently from what the question was asking for. And that's especially true in question 3. So question 3, write a complete bash script. So you're starting with shebang and you're writing, you know, a script that's going to run from start to end. So, you know, these first 2 questions, you just needed, you know, 1 line of bash and a few lines of bash. Question 3, you got to do a whole bash script. And repeatedly does the following. So what does it do? It asks the user to enter a number. It reads a number from the user. It adds that to a running sum, right? A sum initialized to 0. And then keep repeating these 3 steps until the sum exceeds 250, right? So these 3 things happen again and again and again. It's a loop, right? So ask for a number, read a number, and then add that to a running sum. And then after the sum exceeds 250, print out the sum and exit. And so a big issue I saw in some cases was you know, just doing this step in a loop, right? Read a number and just keep adding that number to a sum, right? Which is a different kind of program. Saw a number of issues with how to keep adding something to a sum to accumulate, and then some more minor issues. So let's look at how we could do this. Start off with your shebang. And we're going to keep accumulating values. We're going to keep adding them to a sum. So let's make a sum, initialize it to 0. And our goal is, you know, prompt the user, read a number, add it to the sum. And if the sum does not exceed 250, do that again. So these things that we want to do again, we're going to put them in some kind of loop. We don't know how many times this is going to exit, and we're not allowed to use for loops in bash anyway, so this has got to be a while loop. And we're going to keep looping until this condition is true, until our sum is bigger than 250. So our while statement should list the condition under which we want to continue. So while bracket bracket $sum is less than or equal to 250. Some people said less than 251, that's the same because it's integers. So while this is true, do echo, enter a number, read our number, and then accumulate that. So sum equals sum plus number. And then go back up to the top of the loop and try again. And when you're done, echo the sum. And if that's the end of the script, it'll just exit after that. So, possible issues there. Let me move this over. So still got to use the $paren to do arithmetic. Need the double brackets on conditions. If you just read one number in the beginning and kept adding it, that was missing, a big part of the description of the problem. A lot of people did less than instead of less than or equal to. That's just an edge case condition. But if you stop when it's less than, if you only continue while it's less than, it's possible your sum hit exactly 250 and your loop would exit, and that's stopping one iteration too soon or more. The running sum gives people problems. So and this is all, kind of a derivative of this famous statement, x equals x plus 1, right? Which really says take the value of x, add 1, figure out what that's equal to, whatever that's equal to, now store that in x. Right, so this is this thing that looks ridiculous algebraically, but it's really a read, modify, and then write. If you've done 270, read, modify, write. And so pseudocode here, sum equals sum plus num, takes the current sum of all your input, adds the new input, stores it back in the total. So we call that a running sum or a running total. And if you do something like this, right? That's not accumulating a running total. It's taking whatever sum is, adding your current number, and storing it in total. The next time through the loop, it's going to take the same sum, add the new number, put that in total. Total is not being modified. It's just being assigned a new value that has nothing to do with the previous value of total. So you lose that accumulation from one iteration to another. And if there's questions about these as we're going through them, please ask. All right, so then the 2C questions. So question 4, complete C program. So it's going to be a main program with 2 command line arguments, and calculate the sum of all integers between those arguments and print a line showing the sum. And I gave you an example here. If you say main 1013, your program should take 10 plus 11 plus 12 plus 13. In other words, add up all the integers between there. 10 plus 11 plus 12 plus 13 is 46. Your program should print 46. And for this one, right, don't have to worry about syntax errors. You can assume both arguments are present. You can assume they're valid integers, and the first number is smaller than or equal to the second. So this is the one, exception where you don't have to do a lot of error checking. because, you know, I was going to ask you about error checking here in question 5, and for a timed exam, right, I didn't want you to get bogged down with all of that up here. So, so in this case, you're allowed to be a little reckless with the code, and that will save you time in writing and thinking. All right, so what does this look like? So our main program, it could return void or main, it doesn't really matter. But we're going to process command line arguments, so we need our pair of arguments, which we'll call the traditional argc and argv. Normally, you know, I scream at you, make sure you check argc before you use argv, except that, you know, in this case I said you can assume both arguments are present. So this case, we don't have to check argc. We know that argv bracket 1 and argv bracket 2 are available. So, but they're strings. We need to convert them into integers, and so we can use scanf. So we'll scan the first argument, which is argv bracket 1. Tell scanf we're looking for an integer, and save the result in, I don't know, we'll just call it n1. So there's n1, and then do the same thing with argv bracket 2. And we're not bothering to check the return value from scanf because we've been told in the problem that we can assume that these things are valid integers. So I'm not going to check the return value. I'm also not going to do the %s and get the extra stuff because we've been told that these are valid integers. So here I can just go straight and do my 2 scans. There's my 2 numbers, n1 and n2. And now we have to calculate the sum between all of these. So I'm going to do a running sum, initialize it to 0. And for loops will work well here because we know exactly what we want to iterate over. So we can say let I equal n1 and loop while I is less than or equal to n2. And just add that loop variable to I to sum. And then when we're done, sum should be our running sum. So something like that. So once you've got your 2 integers, you want to add up the numbers between them. You know, start off at n1, go up to and including n2, and just add that variable to the running sum. And some people went back to A to I to convert these things, and that's fine. A to I, if you're not worried about error checking, that'll convert a string into an integer. Or you can use scanf and just not do the extra work. So yeah, some people completely forgot this and just started using argv bracket 1 bracket 2. So that's a deduction. Your sum needs to be initialized to 0. Almost everybody did that, which is great because that's usually a hard battle to convince people. So initialize your sum and then do an accumulation. Now there's other ways you can do this. You could use a while loop if you like. For loops kind of make sense when you have a way to describe exactly how many times something's going to happen. While loops are more when you don't know when you're going to be done, you're going to check some condition. So to me, this feels like a natural for a for loop, but you could do a while loop also. So you could do something like, you know, integer I equals n1, while I is less than or equal to n2. Sum equals sum plus I, and then increment I. And of course you could do I++ instead of I equals I plus 1. But same idea as the for loop, right? I starts off at n1, and we continue as long as I is less than or equal to n2, and at the bottom of the loop we increment I. So this is just a for loop. You could also do something like this. While n1 is less than or equal to n2, that's less than equal sign. Sum equals sum plus n1, n1 equals n1 plus 1. Now this changes the value of n1, but we don't really care because it's just a local variable. And it's just using n1 directly instead of copying it into I. Same thing. So lots of versions of this that'll work really well. But I also saw a lot of versions of this that got a lot fancier. And sometimes the fancier version didn't quite work the way it was supposed to. So for example, some people initialized sum to n1 and then went from n1 plus 1 to less than or equal to n2. Some people initialized sum to n2 and looped while I was less than n2. Some people initialized sum to n1 plus n2 and then looped from n1 plus 1 to less than n2, which actually doesn't work if n1 and n2 are equal, but I didn't get that picky. But lots of different versions of this. And if those are the versions that occurred to you, that's good. Do it the way that makes sense. But if you weren't sure how to do it, or you did that because it was similar to something you did before, right? Outside of an exam, it can be good to kind of like step back and see if there's a different way to think about the problem. Sometimes I've given problems where I said, do this following thing 5 different ways, right? And this wasn't in a test. This was in class at a board. But it's a useful exercise sometimes to, flex all the different muscle groups, your while muscle and your for muscle and so on and so forth.
I've seen that for loop with n1 plus n2 and then decrementing, because it's going to always give you the difference on some challenge problems for like the coding interview.
Ah, right. Oh yeah, this was the other thing I saw a lot of. People decided how many times they would have to loop by taking n2 minus n1 and maybe adding 1, and then looping that many times, and as they loop through, adding n1 plus that loop counter, right? And you can make that work, and it's every bit as good as any of these others. But if it's more complicated to you, if it feels more complicated to you than something else, right? Think about if there's a less complicated way that you could do it, less complicated to you. And these things are always maddening, right? Like the edge cases, should I be less than or equal to, or how many times am I going to loop? Is it n2 minus n1 or n2 minus n1 plus 1? Those drive most people crazy, including me. But the more you practice with them, the more confidence you have in what you come up with. All right, and then question 5 was just parsing a line of user input, right? But this one we had to actually do the error checking. So any illegal input, like any of these or other things, right? We had to throw an error, and you're required to use fgets and scanf, which is the only way we've done this. So I don't think that was a surprise. But you were trying to write a function here, not a main program, right? But just a function. And I gave you the prototype. The function takes no arguments and it returns an integer. So whatever you're going to put inside the body of that function, your function has to start like this. Right? Takes no arguments and is eventually going to return an integer. And despite that, a lot of people insisted on passing arguments to this function. Strings, integers, pairs of arguments, argc, argv pairs, all kinds of things, right? If you're writing a function for yourself, it might make sense to make a function that takes an integer, or a function that takes argc, argv from main, right? But in this case, you were given a specification for the function, which is it doesn't take any input, right? And it returns an integer. And if you look at the behavior of the function, what it's supposed to do, it's supposed to ask the user to enter an integer and then return either the integer or an error code, right? There's nothing in the description about doing something with an argument to the function. And so even if you did put an argument in here, right, there's nothing to do with it. And so if you're expecting a function with no arguments and you put an argument in, best case you'll get some errors or warnings from the compiler. Worst case, your code will segfault. depending on what you do inside the body. So this is the prototype that tells you exactly how you should start your function. And then your function needs to ask the user for an input. So we can print, enter a number. And then we do fgets. And just make it, a big enough array for a number. So we'll have some variable declarations at the top. So prompt the user, get a line of input, that's the ingest, and then we have to parse it. And since we're doing all the error checking, we're going to do the parsing the same way we've been doing it. We're going to do an scanf on temp. We're going to do a %d to pick up the integer, and a %s to pick up any extra stuff that hopefully is not there. We're going to need an integer variable. We're going to need an extra character array. So let's do an extra bracket 120. And then we're going to need an integer num to parse into. And we're going to need to save the return value. And so this is, the code we've written in ODPs and such. So get a line of input, scan it, look for an integer followed by other stuff, save the integer in num, other stuff in here, and save the return value from scanf. Alright, if there is no error, this return value will be 1. So we can say if the return value is equal to 1, there's no error, and what do? We just return the integer that was input, that's just num. If there's anything wrong with this, then return will be something different from 1, in which case we can just say return our error code. And we're done. Now you could say if return is not equal to 1, then return -1. But again, the only way I'm going to get here is if this does not succeed. So if return is different from 1, that's the only time that I'm down here, and that's where I return my error code. Fget should be in standard I/O. Standard lib is where you find things like null and malloc and those goodies. So a few different ways you could do this. You could definitely do this part, a number of different ways, but really your only option up here is, do a print to get a prompt, do your fgets and your scanf because you were told you had to do those. And this is the only way we've discussed to sort of pick up extra stuff. And you got to check the return value. Checking extra does not do the trick, right? If you want to know, did you succeed in getting exactly an integer, check the return value, see if it's equal to 1. Particularly if I'm not initializing extra, checking anything about this array called extra, it gives me no information about what happened in the parse. So check the return value from scanf. And I think that was pretty much it for that question. Oh, the other thing, right? So you're supposed to return a value. Return either a -1 or return the value that the user input. And this function is declared as an integer return value, right? So you're going to have a return statement that returns something that's an integer, -1 num, or something else. Returning is different from printing, right? If it says print, a -1, then you do a printf with a -1. If it says print the number that was input, you do a printf with a %d and you feed it num, and it changes it into ASCII. But when you're returning a value from a function, right, you're using a return statement. And the idea is that, if there was a main program, it could do, something like v equals reader. And when the program gets to this line of the program, it will call the reader function, which will say enter a number, wait for you to type something in, convert it, and if you typed in the number 17, right, this would be basically equal to 17, and v would be set equal to 17. If you typed in something that was a syntax error, then the reader function would say return -1, and all of this would be basically -1, and so v would get set equal to -1. And so you might have done this or seen this in PA2, for example. You might have had a function that tells you how many sticks the user wants to take. And it can, print out, how many sticks do you want, do an fgets, do a scanf. It might have a whole loop in there to keep trying and so on and so forth. But the return from that function is, in this case, just an integer. And a main program could do whatever you wanted. Now, there was no main program required in here. You were just doing the reader function. So you just needed that part of it. But that's what's going on with the return value. It's a way to get a value out of the function back into whoever called the function. So any other questions, comments on any of that?
Prompt is explicitly always asking for like a text dialog to receive from the user, right?
Yeah, so it said ask the user to enter a single integer, so something, enter an integer or greater than sign or something like that. Some sort of message that says, hey, enter an integer. All right, so we'll go back to PA3 tomorrow, and we'll talk more about questions on that. I want to talk a little more about the part that predicts how many guesses it's going to take. So just dealing with logarithms and log base 2, because we didn't do that here on Thursday. Then I want to talk a little bit about strings and this business of wanting the user to type in an H, an L, or a C. We got to do a little bit of funny business to pull that down. And then I want to talk about makefiles and how to put a makefile together. None of that is anything that you need to be making progress on PA3, though. You could be able to make a whole game that runs the whole loop and plays, assuming the user always behaves perfectly and there's no cheating and they always say H, L, or C and so on and so forth, and then keep adding on to that. So we'll talk about that. And then we'll go back to talking about GDB for debugging. So we'll be doing C for at least the first half of this week, and then after that we're going to go back and start talking more about Linux and digging into more commands and more of the idea behind Linux and so on and so forth. So good stuff going on. All right, send me an attendance note on the way out, and that'll do us for today. I will see you next time.